Hey, Mr. Aridum here. We're going to go over how to draw Lewis dot structures of ionic compounds. Okay, since we already know how to name and write formulas for ionic compounds, the first thing we're going to do is write the correct formula for our compound. Okay, then we are going to count the number of valence electrons. We're going to draw the positive ion with charge in brackets. We're going to draw the negative ion with charge in brackets. And then we'll hopefully have the right number drawn so we can cancel them out. Okay? So for instance, we knew that magnesium is +2 and chlorine is -1. Chlorine is -1. So that's how we came up with MgCl2. Okay? That's why there's 2 chlorines here. If we're doing the number of valence electrons, magnesium has 2, chlorine, there's 2 of them, so we're going to have 14 total, so we're going to have 16 electrons. The key is that these 2 electrons here move to the nonmetal. Okay? So when you look at your chlorines here, this has 8 valence electrons, this has 8 valence electrons, and that adds up to 16. Because it started off with 7 of its own, and it's got the 2 from the magnesium. Okay, so let's look at sodium chloride. We know that sodium is +1. We know chlorine is -1. So this is NaCl. Okay, which means we are going to draw a positive Na in brackets, and we are going to draw a negative Cl in brackets as well. Now we are going to do the number of valence electrons. Sodium has 1 and chlorine has 7, so that adds up to 8 valence electrons. Remember, this 1 right here moved to the nonmetal. Okay, so Na started with 1 and it lost 1, so it has 0, and then chlorine has 8 valence electrons. 7 of it started off with, and it gained 1 from the sodium, and that's how you would draw it. So here, sodium lost 1 electron, and chlorine gained 1 electron. Okay, you have to always lose and gain the same number of electrons. Okay, calcium fluoride. We know calcium is +2. We know fluoride is -1. So we know the correct formula is CaF2. So we are going to draw a Ca +2. And we are going to draw an F -1 and an F -1. Okay. Number of valence electrons. Calcium has 2. And there's 2 fluorines, they have 7 each, so that adds up to 14. So that is 16. Remember that these 2 move to the nonmetal, because metals lose their valence electrons and nonmetals gain their valence electrons. Okay, so when I'm looking at my 16 here, fluorine started off with 7 and gained 1, so it's going to have 8. Calcium started off with 2 and it lost 2, so it has none. Fluorine started off with 7 and gained 1, so it has 8. So here, calcium lost 2 electrons, and then 2 fluorines, since there's 2 of them, gained 2 electrons. So each fluorine gained 1 electron. Okay? Now we got to do aluminum oxide here. Oh, this one's the fun one here. Aluminum is +3. Oxygen is -2. So we know our formula is Al2O3. So we're going to need 2 Als that are +3. And then we're going to need some O's that are -2. And let's draw another one for here. Okay, so we have 2 aluminums here. So the number of valence electrons. We have 6 valence electrons from our aluminum. Oxygen has 6, and we have 3 of them. That's 18. And that adds up to 24 valence electrons. Now the key is remembering that these 6 move to the non-metal. Okay? So when we do our oxygens here, our oxygen started off with 6. And it's going to get to the octet rule, so it has to gain 2, so it's going to have 8. Our aluminum here, okay, it is plus 3. It started off with 3, and it lost 3, so we don't draw any. Oxygen started off with 6. And it gained 2 to get to 8. Aluminum, again, plus 3, lost its 3, so we draw none there. And this oxygen, you guessed it, has 8 valence electrons here. So if we are looking at the total here, 2 aluminums lost a total of 6 valence electrons, and 3 oxygens gained a total of 6 valence electrons. Okay? That is what actually happens there. Because ionics are about the transfer of electrons. It's all about electron stealing. Okay. Let's go over the properties of ionic compounds right here. Okay? The first ionic compound I think of is NaCl. So I just try to think of what they do here. It takes a very high temperature to boil or melt sodium chloride. So these are mostly solids at room temperature. And they have a high melting point or boiling point. They are brittle because you can easily crush salt crystals. Right? Many are soluble in water. Some are not. Okay? Which means they dissolve in water, making aqueous solutions. They are non-conductive as solids. But to make them conduct electricity, they have to be in the molten, which is the liquid state for a metal, for an ion compound. That's what that means. Or the aqueous state, meaning that they did dissolve in the water. This allows the electrons and the ions to move, which allows the conduction of electricity. Okay, you guys are champions. The legend is